so in 9.6 day 1, we learned how to solve rational equations, and now we're going to apply that to story problems. Okay, so there's going to be a couple of different types of applications that we're going to do. Okay, so the first one has to deal with rates. Okay, so we're going to create and solve these rational equations. And in example 1, Kathy is paddling her canoe down along the Grand River to her favorite park in East Lansing that is 7 miles away. Because of the current, it's going to take her longer to travel upstream. Okay, have anybody ever gone kayaking in a river before? Okay, so usually in one direction you're fighting against the current, and then in the other one it's helping you along. Okay, so in this case, it says it's going to take her longer to travel upstream, and we're going to let S represent the speed at which Kathy paddles the canoe. So S is going to represent the speed, and this is the speed of the canoe. We say in still water, that means without the current acting against it. All right, so it says suppose the current is 4 miles per hour downstream. Write in equation S if it takes Kathy 45 minutes longer to paddle upstream versus paddling downstream. Okay, so there's some key pieces of information in here. So one key piece of information is that it is 7 miles away. And then we know that because of the current, it takes her longer to travel upstream. And it tells us the current is 4 miles an hour downstream. Okay, and then it also says it takes her 45 minutes longer to paddle upstream versus downstream. Okay, so since this is new for us, I'm going to help you guys organize this information with a very common equation that you may have seen before, either in a math class or a science class. Okay, so we're going to use the distance equals the rate times the time. Okay, give me a peace sign if that is an equation that you've seen before. Distance equals the rate times time. Brand new information for a lot of us. Distance equals the rate times time. Distance equals the rate times the time. Okay, so and then really you see it as D equals RT a lot. So what we're going to do, because we are given these units of time, we know that it's 45 minutes longer to travel upstream versus downstream. We're going to take this and we're going to solve it for T. Okay, so this is the skill that we have worked on. Okay, solving an equation for a variable. So D equals R times T. I want you to write that equation in terms of T. What would that equation look like in terms of T? Alright, so Keenan, how did you solve this one for T?
Divided both sides by R.
Great. Okay, all you can do is divide both sides by R to get T by itself. Okay, so this is the distance over the rate equals the time. Okay, we're going to use this to help us set up part of our equation. Okay, another thing we want to look at here are the units. Sometimes we have to do conversions to make sure that all the units are equal. Okay, so the first one is the distance. So in terms of the distance, they tell us it's 7 miles, and the 4 miles per hour, we can see that it is in miles here. So the unit for the distance is going to be miles. Okay, R is the rate. So the rate, in this case, 4 miles per hour, lets us know miles per hour is our rate. And then our time, this one's a little bit trickier. So if our rate is miles per hour, our time needs to be in hours, or else we have to calculate for miles per minute. The reason why that's a little bit tricky is because the time they give us is 45 minutes. But we can easily change that to hours, right? If it's 45 minutes, what does that equate to in hours? Yep, 3/4. So 45 minutes equals 3/4 of an hour. Okay, so we are going to use that in our equation. All right, so I'm going to help you with logically how to set up your equation. So what we know is it takes Kathy 45 minutes longer to paddle upstream versus downstream. So the time it takes for her to paddle upstream, we're just going to call it upstream time. If we subtract the time it takes her to travel downstream, we know what that difference is. Okay, I'm just going to write time difference. That way you can apply it to similar problems. Okay, so the time it takes to travel upstream, I'm just calling upstream time. The time it takes to travel downstream time, is equal to your time distance. The time difference, sorry. Okay, so we already know the time difference. That's what we converted. 45 minutes is 3/4 of an hour. So we're going to set that equal to 3/4. Okay, now in terms of the upstream time, remember that we solved for t. We said that t is equal to the distance over the rate. Okay, so the distance is how far she's traveling. And how far is she traveling? 7. Okay, so we're going to set this up as the distance over the rate. Okay, so the distance is 7. The rate is going to be her speed. And then we have to factor in the current. So if she's going upstream, she's fighting against the current. So we take her speed and we subtract 4. And this is going to be minus. And then the downstream time, okay, if you guys have done any paddling, you can go faster, right? When you're going downstream, that's because the current is working with you. So if it's working with you, you are going to add the force. Okay, and we are going to just write down a few notes so that you can do this on your own about where this is coming from. Okay, so the equation for S, remember that is for speed in still water. So the S is the speed in both cases. Okay, so when you're working against the current, you're going to subtract. Okay, and then when you are working with the current, that is when you add. Okay, so the distance over the rate gives you the time for upstream. The distance over the rate gives you the time for downstream. And the difference between them, we know, is 3/4 of an hour. Once you have that, this is what we did yesterday. Okay, so we're going to multiply each side by the what? Yep, the least common denominator. So multiply multiply by the LCD to solve for x. Okay, multiply by the LCD to solve for x. So the first thing I want you guys to do is write out what your LCD is. Okay, so the least common denominator. Okay, and that's what we're gonna end up multiplying by. Okay, if you ever have trouble with the least common denominator, just start with the first denominator, which is s minus 4, so that has to be part of it. Okay, the next one, s plus 4, that has to be part of it. The last one, 4. S plus 4 is not the same thing as 4, so that has to go in front. Okay, and then yesterday we talked about how it is helpful sometimes to write out what you are multiplying by so you can cancel them out. So we are going to multiply 4 times s minus 4 times s plus 4 to 7 over s minus 4. We're going to multiply that LCD by the second part of the fraction as well. Okay, and if you're feeling confident and you want to only write that once, you still have to show that you're multiplying, okay? I just don't recommend crossing everything out because I don't want you to cross out and forget to distribute. Okay, because when you distribute, every single piece gets multiplied. Alright, so then when you're ready to multiply, if you have it written out like me, you can cancel out s minus 4 and s minus 4, and then notice what you have left. You have 7 times 4, which is 28, times s plus 4. Okay, I want you to see if you can do the rest here, and then you can go ahead and distribute, and we're going to solve for s. You're trying to get s by itself. Okay, now you do have s squared in this one, but if you don't have anything in the middle, then you don't have to worry about factoring. Okay, and then for here, when you cancel those out, you'll have 28 s minus 4. Yeah, s's are kind of tricky sometimes. Yeah, be careful. You don't mistake it for a 5. That is easy to do. You've all done there. Okay, and then and then you're gonna multiply these two together. If you wanna do that in this step, you can. If you wanna do it in the next step, you can. Alright, so when you distribute 28, you get 28s plus 112. And then be careful on this one, because you have a negative times a negative, it's, yes, so those are gonna double. Now here, you can either distribute the 3 and then FOIL. I think it's a little bit easier to FOIL first because it's the difference of two squares. Okay, so you get 3s minus 48. And then 28s and negative 28s, those are going to cancel. But the 112 and the 112, those double. Okay? And I do love that you guys were thinking of factoring and you moved everything inside of equal to 0. If you don't have the s, instead of factoring, you can take a square root. Okay, so we have 3s squared is equal to 272. And then be careful when you get here, because when you divide, you're not going to have an exact value. When you divide, you would have to round it. So if you do 272 divided by 3, keep that in your calculator. So we're gonna write out that you are not rounding that early. Okay, so I'm gonna keep it as 272 over 3. Okay, and then do not round early. You can use the answer key in your calculator. Okay, and then when you take your square root, you can either do the square root of second answer, or you can do the square root of 272 divided by 3. Okay, so you're not going to round until the very last step. I just don't want you to round this to 90.7, because it says to round to the nearest 10, and take the square root of that. I want you to leave it exact until you get to the last step. Now, normally we do the plus or minus, but remember that this is going to be representative of what? Not the time in this case, but the speed. So the quantity has to be positive. The speed is always positive. Okay, and then your final answer, make sure you include your units. Okay, so S is going to be 9.5 miles per hour. That's your speed. Alright. Then when you're, yep, the 9.5 is in miles per hour. Okay, and then for the next problem, this is another one that has to do with rate. So we're still going to be using that same equation. Okay, so I'm just going to write at the top the distance equals the rate times time. So we're still using this. Okay, and this one is going to focus more on the rate. So if I solve this for R, the rate is equal to, I'd have to divide both sides by t. So it's the distance over the time. Okay, so we're going to keep that in mind for this problem. Okay, so Natalie can finish a 500-piece puzzle in about 8 hours. I was going to say Natalie's 2 years old. We don't know how old she is. Okay, and then when Natalie and Renzo work together, they can finish it in about 4.5 hours. Okay, about how long, so anytime they're asking you how long, that means you're going to be finding the time. So how long will it take Renzo to finish a 500-piece puzzle if he works by himself? So in problems like this, there's always going to be some kind of task that people are working towards. Okay, that's going to change depending on the problem. What we're going to do is we're just going to organize the information they give us. Okay, so our information for Natalie is that she can finish one puzzle in 8 hours. Okay, in this instance, the puzzle is the distance. So when we're writing out the rate for Natalie, her rate is one puzzle in 8 hours, so it's 1/8. Okay, so that's how we're going to write it as a rate. So the 500 in terms of this problem is just referencing the puzzle. So it's just an adjective for the puzzle. It's not anything we have to calculate. Okay, now Renzo, we're trying to find out how long it will take him to do one puzzle. So one puzzle, we don't know how many hours. We're going to call that T for time. Okay, so his rate would be 1/T. Yep, and then if they're working together, you have 4.5 hours. Oh, sorry. For one puzzle. Okay. Would be 1 and 4.5. Alright, so I'm going to give you an equation that you can use anytime you're doing what I call a task problem. In this case, the task is a puzzle, but it's not always going to be a puzzle. So, you can always take the rate of the first person. I am going to plug in Natalie, but you'll be substituting. Depending on the problem. So you can always take the rate of the first person and multiply that by the time together. Because if you multiply the rate times the time, that's going to equal the distance. What did we say our distance was in this? One puzzle. So this whole thing is going to equal 1. Okay, and then if we take Natalie's rate and the time it takes her to work with Renzo, we can take Renzo's rate and multiply that by the time together. And that's going to be equal to 1. And I'm just going to call this a complete task to make it easier for you to apply that to whatever people are working on. Sometimes they're painting a room. Okay, so it's the rate times the time together plus the rate of the second person times the time together. That equals one complete task. Okay, so for Natalie, it's going to be 1/8 multiplied by the time together is 4.5 plus Renzo's rate is 1/T. Their time together is 4.5. Okay, and that is going to be equal to 1. One complete puzzle here. And once you have that set up, now you can just solve it for T using the skills that we've learned in this section. So if you're multiplying a fraction by a whole number, just remember and multiply it by the numerator. And then once you have this, now we can multiply each side by the LCD. Okay, so that is how I want you to solve these. Multiply it by the LCD. And again, if you're having issues with picking out the LCD, we just look at the denominators, right? So what is our LCD going to be for this? 8t. So 8 is in the first one, we need that. T is in the second one, we need that. Okay, so if we multiply 1 by 8t, that's going to be on this side. And then when you multiply this whole side by 8t, okay, you're distributing. So like I said earlier, sometimes I just like to write it out next to each one. So distribute to this and distribute to this. And you can do your cancellation. Okay, so when you're doing the cancellation here, the 8's will cancel. You have 4.5t. Here the t's cancel. You're doing this without your calculator. What's 8 times 4? 32. 8 times 0.5. 4. 4 plus 32. 36. Okay, and then we're going to get all the t's on one side. Okay, we are going to write our answer in a specific way. Okay, so you get 3.5t. Okay, so then we're going to divide each side by 3.5. Okay, now when I divide that, I get this long decimal here. Okay, and in this case, the time is in terms of what unit? Hours. So a lot of times we don't just leave something in hours and say it's 10.3 hours. We're going to convert this in terms of hours and minutes. Okay, so right in terms of hours and minutes, and we're going to round to the nearest minute. Yep, we're going to talk about how you can set that up. You guys have probably done some conversions in some of your science classes, like maybe you've converted with moles. Have you done that setup yet? All right, so we're going to convert, okay, hours to minutes. Okay, and really, once you guys do this, you don't have to set it up like this, but I want to show you why that works. So in this case, we know that the 10 is going to be our hours. So we know that we're going to have 10 hours. We just have to find the amount of minutes. Okay, so we can just subtract 10, because we already know what that is, and then we have to convert this decimal. So the way that we show that it's the unrounded decimal is we put like a dot, dot, dot. Okay, and if this is the time in hours, when you guys are setting up the conversion, how does that help you decide whether you're multiplying by 60 or dividing? Like, how do you know whether you're going to multiply by 60 or divide? Yeah, so if hours is on top here, where does the hours need to be in our fraction? On the bottom. Okay, so if this is hours, this is minutes, right? Is there 60 hours in 1 minute, or is there 60 minutes in 1 hour?
60 hours in 1 minute.
What? 60 minutes in 1 hour. Okay, so then when you convert, you can cross those out. The hours, okay, that's how we end up with minutes, and that's how you can see that you'll multiply those together, and then that's what we'll round to the nearest minute. So again, we're not rounding early, so we're taking what we have in our calculator, we subtracted the 10, so we only have our decimal left, and we're going to multiply by 60. Okay, so 17.1 rounds to 17. Okay, so it's 10 hours and 17 minutes. Yeah, we didn't divide, so we're just multiplying those together. we're multiplying by the conversion. So 60 minutes and 1 hour is the conversion, so you can see it for those. Okay. And then it's full day activity for these scales.
So I'm sorry. How does it take you prescription drugs to take you
Well, respectfully, we don't know how old they are. They could be 5 years old.
500
Welcome to JP.
2 hours.
All right, and then our last application also has to do with something you may have studied in science, the rubbing alcohol, the isopropyl alcohol. Yeah, you guys work with that this year? Okay, so typically the rubbing alcohol, which is something you might find in your medicine cabinet, right? Okay, that contains 70% of the isopropyl alcohol. We are going to suppose we are adding, I'm going to do 50% isopropyl alcohol liquid to 200 milliliters. So we're taking a solution that's 50%, and we are adding that to 200 milliliters of a liquid that is 91%. Okay, we are going to write a function that represents the percent of isopropyl alcohol in the resulting solution. So that is our new solution after we combine those together. Okay, so the resulting solution, I just like to say, hey, this is the new solution. Okay, that is going to be the result when we add the 50% to this 200 milliliters. Okay, and this is our original. So this is what we already have. We have the 200 milliliters of a liquid that's 91% isopropyl alcohol. Okay, we are going to add an unknown amount, so we're going to call that X. Okay, X is going to be the amount of 50% alcohol solution added. Okay, so we have two different solutions. I like to organize this information in a table. Do without the Scots today. Okay, so we're going to make a table as fast as we can. We'll start with a rectangle.
Like an actual table?
Like a chart.
No, I was like, this is not a table. So I always think of this graphing tables. So I was like, I don't know what this stuff is.
No, yeah.
An actual
Okay, we're gonna make a chart.
I was expecting just the like three like the lines, but then you make a box.
I was not ready for that circle.
Oh, like an X and Y. Oh,
Alright, so in our table, we're gonna label these columns original, added, and new. I did. I started with a rectangle, and I added these squares on. Alright, and then our first row, just trust the process. Okay, so our columns are original, added, and new. Okay, our rows are isopropyl alcohol, and the total liquid in milliliters. Okay, so what we know is the most information about the original because we have the amount in milliliters. All right, I'll wait till you guys have your charts down. So the what? All right, so we're going to start with the original. So in the original, you have 200 milliliters of the 91%. Okay, so for the total liquid, we have the 200 milliliters. Okay, and then the isopropyl alcohol, if it's 91%, we're going to calculate 91% of 200. Right now, we're going to leave that as an expression. So the way we write that is 0.91 times 200. Okay, eventually we are going to multiply those together, but for right now, we're just going to keep that. Okay, and then in the added is what we are going to add to this original solution. So it says X is the amount that we are adding. So we're going to say this is X milliliters. And then what is the percentage that we are adding of the isopropyl alcohol? 50%. So 50% of, in this case, is going to be X, because we don't know how much we're adding yet. And you can either write that as 0.50 or 0.5X, whichever one you want. Okay, so remember, we are combining these two together. That is what we're going to get to equal the new. So when you add these together, you're going to have 0.91 times 200 plus 0.5x. Okay, our new solution consists of the original plus the added. Okay, so your new is just combining the original plus the added. And it's going to be the same thing for this one. Okay, so the original is 200. The added amount is X. So it's going to be 200 plus X is our new total amount of liquid. Okay, when you are writing a function that represents this, you're going to set up a general equation first. Okay, so the function is the amount of the isopropyl alcohol. Making my L too soon. And then the total amount of the liquid. Okay, so the percent is calculated by doing the amount of the isopropyl alcohol over the total amount of liquid you have. Okay, so it's the isopropyl alcohol over the total amount of liquid. So for this function, we're going to take what we have in our table. So the amount of the isopropyl alcohol is what we calculated here. Okay, so the isopropyl alcohol is the 0.91 times 200 plus the 0.5x. And if you wanted to simplify that here, you could. We're going to do it in the next step. Okay, and then the total amount of liquid is the 200 plus x. So this is your function. Remember, a percentage is always out of the total. So that's why you have the isopropyl over the total amount. Alright, so we're going to use that in part B. So this should say how much of a 50% isopropyl alcohol should be added to create a rubbing alcohol that is the 70%. Okay, so how much of that 50% should be added to create rubbing alcohol? So all we have to do for this one is that our function, we want our function to total 70%. So if we set our function equal to 70%, we're going to write that as a fraction. So again, we can use the skills we've been working on in this section. So our function is 0.91200 plus 0.5x over 200 plus x. And then 70%, how can you write a percent as a fraction? As a fraction. So you can write 7/10 or 70 over 100, either one is fine. Okay, 7 over 10 is the reduced form. Okay, and then if you want to think of the percent as over 100, that is fine too. Either way, you're going to get the same answer. Okay, as long as you have an equivalent to 70%, that is fine. Okay, so just like we have been doing, we're going to multiply by the LCD. So the LCD is 200 plus x times 100. So 100 times 200 plus x. Okay, so I want you to multiply both sides. And then go ahead and cancel out what cancels. Okay, and then you're going to be solving this for x. All right. All right, let's see how this went. So once you multiply, here these are going to cancel. So you have 100 times, and then when you do 0.91 times 200, what did you get? 0.91 times 200, yeah, what did we get?
91 times 200.
182 is right, and then 0.5x equals, and then I did this in the next step. Okay, so then when you're multiplying those out, you have 18,200 plus, and really when you're multiplying by 100, aren't you just moving the decimal over? Yeah, so 7 times 2, 14, and then you have the 3 zeros plus the 70x. I like to get my x's to where this is going to be positive, so it's equal to 20x. And then if I subtract 14,000, then we get 4,200. So when you divide by 20, okay, when you're doing this, that's why it takes time to do this. So the 420 divided by 2, you should get 210, and then you're going to put your units on there. Yeah, when I give you this time to work, that's because I want you guys to do that on your own, so you can just check it with mine. Okay, so once you cancel those out, you're just going to distribute. Okay, that's something that you have been doing, and we've been doing that well. Okay, and then I'm also going to put up the calendar for what we are working on tomorrow.